Hello everyone, I am Parth Rajendra and I am studying in second year electrical engineering of KBT College of Engineering, Nashik. Today we are going to discuss about digital storage oscilloscope means DSO. What is DSO? Its operation, its principle and its comparison with analog oscilloscope. We can get started with our presentation. What is DSO? Means digital storage oscilloscope. Digital storage oscilloscope is the digital form of analog CRO. It's the replacement of CRO. Digital storage oscilloscope, as we are going to define it, its definition is an advanced electronic instrument that captures, stores, as well as displays electrical signals digitally in digital format. Why we need the DSO instead of CRO? There might be some reason for replacing CRO with DSO. So we are going to see these reasons. Analog real-time display only means CRO only displays analog real-time data, but in DSO we can able to store this data and display it whenever required. Digital means when we say about CRO, it only stores and recalls waveform and better accuracy, but CRO has better accuracy and advanced measurement capabilities. This is absent in DSO, but due to some advantages, still the DSO is more preferable than the conventional CROs. Key difference is in one line we can going to say is converts analog signal to digital data for storage and analysis purposes. Next. Why do we need DSOs? As I said in earlier slide, analog CROs limitations. Due to analog CROs limitations, we are need to change or replace the CRO. No waveform storage, as usual in CRO there is no waveform storage. Transient signal lost. When some transient signal appears across the CRO, it lost its signals. Limited measurement precision. It has less precision than that of DSO. Storage capabilities. Our DSO captures and analyzes and as well as stores the data. This is not possible in CRO. High speed signals. In electronics, there is one requirement is high speed signal processing. It's we get in DSO. DSO is capable for high speed signal handling capabilities. The basic principle of operation. DSO works in three basic principles. We are going to learn this. What is these three basic principles and how it works. First one is data signal input. It's the basic it's basic stage of every electronic component. It's data input. So first principle is ADC conversion. Samples and digitized signals into binary values. DSO converts analog inputs into digital outputs. Digital storage stores waveform data in memory for reconstruction or in memory banks. DSO offers this functionality. Display output reconstructs and shows the waveform on digital display. Display unit of DSO is called as CRT, means cathode ray tube. And when we move towards the next slide, we can able to see the block diagram of DSO. It's important topic. Here is the input attenuator. It means it's also often called as input amplifier. Input amplifier means it's amplified the input signal for better measurement purpose without changing its magnitude. It only amplifies the digital input. Sample and here is the vertical amplifier, means when data is fed to attenuator, it amplifies fully amplify. Sample and hold circuit. We learned sample and hold circuit in another subject of electronics. It's called as analog and digital electronics. This circuits is used here in DSO. Analog to digital converter. It's called as ADC. This is the component which converts analog data into electronic pulse data. Here this is the analog input and it's the digital output. Here is the memory circuitry. In memory circuitry, this digital output enters in the memory and outs towards the control logic. Control logic is communicate with sample and hold circuit, and it's fed by the trigger circuit. Here we can see amplified analog input is fed to control logic, and control logic sends data to horizontal digital plate, which again converts the digital data into analog. And here is the horizontal deflection amplifier, which again amplifies this waveform without changing its properties. Okay, and same thing happens with vertical deflection amplifier, which is the outsourced from the memory through the address bus and fed to digital to analog converter. Again, digital to analog conversion takes place. Here is the amplifier, and here is the cathode ray tube, which directly indicates what display it is right now. Done. Now we see the working or architecture or explanation of block diagram. Input attenuator, it's also called as input amplifier, which scales down high voltage signals to safe measurable values. Amplifier storage boosts weak signal for accurate digitization. And ADC means analog digital converter, which converts analog input into digital output. Memory unit is used to store the input data for output on the CRT. Time-based and trigger circuit control samples rate and synchronize with display. Time-based and trigger circuitry which synchronize with the display for time-based. Time-based means the input and y and x axis of the waveform. Display system reconstructs that input or output data from the memory to visually represent it as a waveform on CRT. How DSO works? This is the picture of DSO. We can see here the multiple buttons. This is the cathode ray tube, and here the input probes. So in first stage of working of DSO, it's the signal acquisition. Input enters through the probes and connected to the test points and level adjustment. Then amplifier conditions the signal to optimum range that's required for the further conversions in the DSO. Sampling and conversion. After the amplification, its data goes to sampling unit, which converts analog signal into digital with regular time intervals. Data in binary forms. Data storage. Digital values stored in high-speed memory buffers. Here we are used high-speed memory buffers, which stores the digital data. And waveform display, what input we would apply on the test probes is as it is displayed on the display or CRT. Next slide is key features of and advantages of DSO. When we say advantage or key features of DSO, very first and essential advantage is high accuracy. It has precise memory and figure-free display for minimal drift. It's the major advantage of it. Storage and recall. Serves multiple waveforms, compare signals and analyze history data, which are required in many applications. We can get that advantage in it. Auto measurement. Instant calculations means peak to peak voltage calculation, frequency and time period, duty cycle and rise time calculation is automatically takes place inside the DSO. On this display section, here we can get this all the measurements. We don't need to do it on the paper. Transient capture. As we know, when the transient input appears across the CRO, it wouldn't show the output. But this problem is resolved in this system, in DSO. Here we can record the single shot and rare events that analog scopes miss. PC connectivity. We can also able to connect our DSO along with the PC through the LAN cable or LAN port is provided on the DSO. If LAN port is absent, then USB port is there. We can connect our system easily with the DSO. Compact design. As we know, the size of analog CRO is too bigger, and this comes in the compact size. Modern DSOs offer portability without sacrificing performance. We can get the same performance as CRO offers, even better performance than the CRO in compact size. Real world application. We would learn how DSO works, what is its advantages. Now, why it's applicable, or what is its application? First one is the circuit testing in the troubleshooting of electronic equipment, debugging the signal and verifying the components. DSO is used. Another application is digital systems. We can able to use the DSO for analyzing digital logic levels and timing diagrams. Okay, power electronics. In the power electronic industry, for studying the switching of waveforms and PWM signals, inverter outputs, and harmonic analysis, it's very crucial in the power system sector, where we can use DSO. Research and development labs, like in schools, colleges, not schools, in colleges, universities, the DSO is very useful for research and development on or in the companies where the electronic components are manufactured. Their DSO plays a key role in that industry for increasing the efficiency of the process. Limitations. What limitations come along with the DSO? First limitations is the higher cost. As we know, if any electronic components is upgraded from its one form to another to increase efficiency or increase portability, the price factor is there. The price of system is increased ultimately. This is also happens in the case of DSO. Sampling rate constraints, limited ADC and memory depths, which causes to memory very high frequency may require specialized model. As we put too much memory pressure or very high amplitude of the analog inputs, DSO is not capable to handle that pressure. So there we need specialized model which are designed for these applications. Learning curves and memory limitations. DSO is a has finite storage to store the memory, and its advantages. We require more memory to display the continuous discrete output. So conclusion is that why we need to switch from the CRO to DSO. The first is the modern standard. DSO now becomes the modern standard for the industry. Digital advantage. It stores, analyzes, and displays the signal with unmatched precision and flexibility. It has the flexibility to work with the PC or modern computer systems, and has the very much high precision which are absent in the CRO. It's the CRO replacement. It successfully replaced the oscilloscope in virtually all professional performance and applications. Thank you all. This is we learned today's topic DSO, and learn why DSO is better than the CRO. Thank you.